So next up is Stefano and Antonacci from the Montreal area, is the regional sales manager for Valmet and formerly of Metso. He received a degree in electrotechnology from Vanier College and has 39 years experience in process automation and controls in the wastewater industry, and also in pulp and paper and in mining. Welcome.
I'll also try it from here. Well, good afternoon. So those were all very interesting presentations, tough to follow. Those are good presentations. We're going to talk a little bit about optimization and through automation. And so just to give you an idea about Valmet in brief, let's see, where's the pointer? Here it is. Okay, so, okay, that works. Okay, so Valmet in brief, we're a global developer and global leader, supplier of technologies and automation services. Pulp and paper is a big market for us, energy, and also industrial and municipal wastewater treatment. We have about 13,000 professionals around the world working for us, and our sales yearly is about 3.3 billion euros. Okay, so in North America, we've got 17 service centers, 7 production units, and 8 sales offices for about 1,600 employees. Most of our support for automation is done in the Georgia area. So what's Valmet's offering for wastewater management? So what we're offering is advanced measurement technology and controls for municipal and industrial wastewater treatment through dry solids management. Okay, we have these tools available for users out there, operators, and they revolve around solids measurements online. So that would be all over the sludge circuit, from primary clarifiers all the way to cake measurements. Again, online measurements. And we kind of close the loop with specialized samplers that allow the customer or the user to take safe, accurate, repeatable manual samples in the field, and close the loop with advanced control packages using solids, online solids measurement. Okay, continuous online. So what we're trying to do is challenge the way to optimize processes. There's still a lot of processes in the wastewater treatment industry that rely on a single point measurement. That means a snapshot in time. So a lab measurement. Based on the lab measurement, we take a grab sample. Based on the result, we take a certain action. Unfortunately, that point in time does not always tell the whole story. There's a lot of variability that the operators are missing by using this type of practice. So by going online, you can get a lot more information and take more intelligent control actions. So with what we have, the Sludge Dewatering Optimizer, so which we call our acronym, the SDO, and associated online measurements, with these combinations, we can more effectively control the process through the plant. Okay, so we have proven technology, been in the field for quite a few years measuring solids. We have all the centrifuge solids measurements covered from front to back. We have over 40 years experience in solids measurements in different industries, and those would be pulp and paper, mining, and wastewater treatment. and we have reliable real-time results with these online measurements. We close the loop with this Valmet Sludge Dewatering Optimizer, and what this basically this optimizer is multivariable controls. Okay, it's based on reliable hardware that's in use worldwide, and we custom develop applications for customers and their process. And with this type of technology, the customer or the user has 24/7 basically optimization with the real-time measurements. So if we look, for example, this is how we would equip a centrifuge. So we have the inlet solids measurement capability, we have the cake measurements capability, centrate, and then we close the loop with the SDO. All right. So the TS measurement can be used either on the front end or the back end, measuring the cake online, whether if it's pumped on the cake side, and of course on the front end it's pumped. So this type of equipment could measure total solids ranging from about 0 to 40% solids. It's a real-time measurement, and it has a very, very wide application range. It doesn't care whether you're pushing primary or secondary sludge through it, or what the sludge composition is. There's no moving parts, and it is completely not, I would say, solid state type technology. So there's no maintenance involved in this type of measurement. All right. We have a specialized centrate measurement that provides continuous feedback on how the centrate is operating. And in recent years, we've developed an online dry solids measurement that gives us the measurement of solids, cake solids coming out of a centrifuge or any type of dewatering equipment if it's free falling. So if it's being conveyed, we can actually grab it, convey it through the instrument in a continuous fashion, and give a continuous output of what the cake solids is. All right. When we look at, for example, a centrifuge or centrifuge operation, a lot of the parameters or control variables are interactive. So if you're moving polymer around, if you're moving torque around, it has an impact on more than one variable. So that's why we use MPC control in the SDO. So it's multivariable predictive control. So we build models on how the process is behaving, and we will predict what the reaction will be to a certain change in the process. So if we get a change in sludge flow, and at the same time there's a change in polymer addition, or we make a polymer addition change, we will predict what that will be coming out of the centrifuge, or what that will be, or the impact will be on the centrate. And we take actions based on those predictions. And they're self-correcting because of all the online measurements that we have that are continuous. And our structure is modular. So just to give you an idea, this would be like a first step structure. So we have the sludge dewatering optimizer. Typically, input values we're looking at is Valmet TS before the centrifuge, so that's solids measurement being continuously measured, and the flow measurement going to the centrifuge. The control output values are typically usually polymer set point and sludge feed flow. All right. So that's just based on input values of the sludge going to the centrifuge. We could add a second variable on that, or another variable on that, which would be centrate solids, for example. All right. So this is another input value which would further give us insight into polymer set point and sludge feed flow set points. Let's call this maybe option 2 of the second modular approach, where we could add dry cake solids, continuous measurement of dry cake solids. Then we have output values we can interact with the torque set point by having this value coming back in a continuous fashion. And if we looked at, an all-dressed situation, we would have input flow or flow and solids, centrate, and cake solids being fed into the sludge dewatering application. And these are all the input values which we typically look at, and output values which we manipulate through the control system. So if we look at the modular approach and we look at performance, for example, if we're working normally off of just manual control or manual interaction with continuous measurements based as a baseline, what we've seen with the plants that we've worked at, it just by adding that first step, just by adding control based on feed solids and feed flow, so going from adding polymers based on flow to, let's say, in kilograms per ton, right, or grams per ton, we've typically seen savings around 20%. So that's a pretty good step. If we had dry cake control to that and centrate, we can definitely jump into the 40-50% range. And if we add the full SDO package, we get quite a big jump in benefits right there. All right. So one of our customers, the more recent cases, we did an early estimate with them. It's a European case, and in their case, we projected they would save about $110,000 per year, just on one centrifuge. All right. The year of operation is that they were able to save just short of 160,000 US. And the savings was in returned centrate solids, polymer consumption, and also the bump in solids in their cake allowed them to save money in transport for landfill. And I believe my time's up. Any questions?
Is there an element of your programming logic that takes into account the efficiency of the motor of the dewatering equipment, like and accounts for that and savings? Like, I might up the torque and improve my solids, but now all of a sudden I'm running higher in the curve and then I'm not running my motor as efficiently. Is that part of the logic?
We could, if you have an amperage measurement and we can measure it, we can put that in the model. Was it part of the study calculation? That I don't know. I doubt it. I doubt it. Yeah, no problem.
Is there a way to measure the polymer in the centrate? Like when you're overdosing, polymer escapes into the...
I'm not aware of an online sensor that can actually measure residual polymer. We don't manufacture one, but if there was one on the market, we could include that in, like we have, if we look at our SDO, we have a lot of IOs, and every case is a little different, right? I'm giving typical ins and outputs. So like with one SDO, we could easily control up to 4 centrifuges, right? But we have a lot of IOs available to take in more information.
So how many of the full smart dewatering systems have been implemented, and what has been the payback in polymer savings or whatnot on average between the different operating facilities?
I don't have all of them here right now, but we're looking at about roughly 4 installations right now between Europe, and there's a few coming online in North America over the next year. I can tell you safely, without even going to the SDO, we have cases of at least 40–50% savings in polymer. That's just going from having no instrumentation to having online instrumentation. The low-hanging fruit is really just going from manual, flow addition of polymer to percent applied. I call it percent applied. I don't know if it makes sense to you. It's basically going to kilograms per ton or pounds per ton polymer added. It's a huge bump.
So is your system taking over control of the centrifuge itself, or just the polymer feed and the sludge?
Yeah, we won't take over the centrifuge manufacturer's panel. What we do is we sit over top of that and kind of act like an operator and manipulate all the process variables for the operator. Now, our system has, think of it as when you're running with our system, you're not looking at set points anymore. You're looking at ranges of operation, which are set by the plant, with us. So if you're looking for a centrate solid, let's say ideally would be 400 parts per million or milligrams per liter. If your objective is to reduce that to a maximum, you put a range in the system, and it's always hunting between a certain range to try to maximize that efficiency, right? Same with polymer addition, same with cake solids. If your cake solids you can accept between 26 and 27 or 26 and 29, it's going to try to optimize within that range. The operator is in charge of what he wants.
Your system that adjusts the polymer feed and the sludge feed to the
Yes.
work on belt presses, screw presses?
Yes. Any dewatering equipment. Good. Thank you.